Yeah, so I was going to talk about DAOS. It hasn't been talked about in a while, so I figure I'd give you an update. So just as a reminder, DAOS is something Intel has developed. It's starting to show up on some of the machines, especially at Argonne. And we had a project with them to develop a plugin or a vol connector that talks to DAOS. So if you DAOS can handle POSIX calls. So if you have a POSIX IO you're doing, it can handle capturing those calls, HDF5, which I'll talk about. Also, if you use an MPI IO, there's also an implementation that uses DAOS that connects to the DAOS engine here and then writes to either NVMEs or whatever you have underneath in the DAOS object store. Move this out of the way. Okay. So in terms of HDF5, the vol architecture, you have the tools, you have, of course, the HDF5 API, and you have the vol layer. And we also added another test to test DAOS, external test suite that we're trying to move back into the library. But as it stands now, it's a standalone test. It's a vol tests repo, and you can find it in our HDF5 repo. And basically, it tests all the DAOS functionality that we developed for it. And it's very extensive. So even if you're not interested, if you're developing your own tests for your own vol, it's a very useful test to look at because it's very rigorous and very covers a lot of APIs. So it's always a good example to model your tests after if you're developing a vol yourselves. And then you have the DAOS vol, which I'll talk about later, which talks to the DAOS layer, the object store. There is another option, and this won't be explored in this talk, but since DAOS can use the MPIO, it can capture MPIO calls, you can just use the native vol, load the MPIO driver, and then use their DAOS enabled MPIO that can talk to DAOS. But it's still advantageous to use the DAOS vol because it's kind of tuned for HDF5, whereas this is not tested by us, at least. This is mostly Intel is developing and maintaining that layer MPIO. So it's always not guaranteed that this native vol will work with MPIO with the DAOS underscore under storage. You can actually update this. It works with 112. Now it'll be 114 because all vols have been updated to 114. So you'll need to be at least running HDF5 114. The DAOS vol connector you can find on a repo, and our external test suite, which I mentioned, is the vol test. And it works with all the tools. So if you want to H5 dump your DAOS object store, you can use H5 dump or H5ls, H5 diff, and you can also repack it from a DAOS vol to a native vol, for example. So if you want to build the DAOS vol connector, it is available in SPAC. We're in the process of updating it. I think it's been updated for 114 and works. So I don't know if it works in SPAC yet. We're still working on that. So should be working in the next few months if it's not already. You can build it with CMake, which is not as convenient as doing it with SPAC. And this is some of the commands that you can use to build it. And there is a user guide in the source in the doc directory that contains some of the information. So more up to date. So you can, if you want to start using the DAOS vol connector, you can do it in two ways. You can either set the FAPL, so there's an H5P set FAPL DAOS. You can use that, and if you use that in your code, then of course you're adding that into your code, and you'll have to link to the public headers and the library itself, the vol, so it can find this. The other option, if you don't want to add this to your code, is just use environment variables. So you can set the HDF5 vol connector DAOS, and then you set the plugin path to that where you compiled the DAOS connector. And depending on your implementation, how your system admins is set up DAOS, you may need to set a DAOS pool. In DAOS, there's also something called Unified Namespace component. What this allows you to do is you'll create a DAOS file, and as you would typically do, and what you'll see on the file system is that is the file that so if you create, say, for example, example.h5, then you will see, if you do an ls, you will see the example.h5, but the file will be basically empty because that's just a way to point to the DAOS container. So that's kind of nice that you can ls and use it, for example, the tools to use that namespace instead of actually trying to find what the container looks like in the DAOS environment. And another advantage, if you use the namespace, you don't need to include the pool because the pool is already included in the namespace of that file. So just a reminder is that important key when you're using DAOS is if you want to be able to use the more than one DAOS server, then in order to get good performance from it, you need to use data sets that are chunked. And in HDF5, you can either do that by if you give it a contiguous data set, it's automatically going to chunk the data set. And you can give it a size. You can play, I don't remember what the default is of the chunk of a data set, but you can increase that if you're given a continuous and you don't want to change your code to do chunked. You'll probably get better performance though, because if you know that if you can set your chunking layout yourself, that might be beneficial. And so you might get better chunking performance if you set it yourself. That just allows you to use more than one DAOS server if there are. Otherwise, you won't really see a advantage to using more than one server if they're not chunky. I think you can suppress chunking. Let me see, the DAOS vol to not chunk the data, but in that case, you won't get that great a performance if you do that. Another thing is the majority of the features in HDF5, compression's currently not supported with the DAOS vol, and neither are any of the APIs that have to do with a native file format that you would find. Some additional features though that you'll find with DAOS is you can do we have map objects, so you can do key value objects. There is a new APIs for file deletion. So in DAOS, it's not straightforward, especially if you're not using unified namespace, how to delete an object in DAOS. So those APIs kind of help you do that. You can also support independent metadata, so you can independently create metadata. And it also supports async IO. There's also another vol that does async. So there's two vols. If you're doing async, if you're calling the HDF5 async calls, you can either use, there's a vol that uses pthreads essentially and handles all the async calls. It's a pass-through vol, and it creates its own server and does all the calls for you. Or you can use DAOS. Those are currently the only ways to do true asynchronous data calls. One thing is, so when you do async calls, you have an event set. So you basically, this is the event sets implemented at the DAOS level, and then it uses the DAOS task engine to schedule those event sets. And so eventually, basically, you call the API and then it returns before the operation completes, and that operation gets set to an event set ID. When you do that, though, you have to be careful that you don't overwrite memory that's currently being used. So you want to avoid a mem copy or memory mods of an async buffer, just like you would any other when you're doing async. You can, I think right now it copies the data. I think there is an option to either not copy the data and make sure you don't touch it, or copy it to the buffer and then be able to move and modify that buffer. So we did do an example with explicit async. So the idea was, for that we used the VPIC application, and we wanted to overlap computation with IO. So there was not a lot of overlap, or we kind of did a pseudo, since we used an IO kernel, we put in pseudo type computation. So in that we changed to using we added the async APIs, and then we had 3 event stacks. Since they do IO in 3 stages, they have particle, hydro data, and field data. So we had 3 event sets for each. And so I kind of gave a picture of the outline of how that works. So you had the particle or particles. So for example, at the first time step, it would create a particle event set. Then it would write the electron data. You would do a wait, just because this isn't the next, if you want to cycle through this, you need a wait. The way that it currently progresses in async is it progresses during the wait. So if you don't call the wait, it won't progress through the stack. So you call another way to do the eon. So you see if any event sets, and you can get the number of event sets in that stack. Then you go on to the hydro data. You check the event set of the particle data again. And then you also create a new event set for the hydro data. And you check both of those with a wait. And then you go on to the field data. Again, check the particle data and the hydro data, see how long they progressed. And then the field data is the next field that you add. Then you do a computation, and for this we waited on the hydro data and the field data to complete before we go on to the next time step. So if you look at now the timing for each of those, so you have the fields, the hydro, the particles. These are all different values that they output. So this was run on the number of processes as 16, 32, and 128. And this is the time. So you can see it's the first columns, the synchronized output, and then the second column is with async. So you can see now the wait, there was not quite enough time for the computation to overlap completely the writing of the fields. So you can see it kind of waited a little bit in the fields before going on the next, but it's still advantageous to use the async for all the cases. Some tools that you can use. So as I mentioned, you can use H5 repack. For example, this is going to be pretty important if you want to maybe archive your file somewhere else in an HDF5 file. You want to convert the DAOS object into an HDF5 POSIX file, or you might want to do it vice versa. If you have a POSIX file, you might want to first convert it to a DAOS file and then read the DAOS file directly. You can also use H5 dump to view the DAOS file, and you can do H5 diff between, for example, the POSIX file and the DAOS file. Some things when you want to port your application to DAOS, keep in mind that we ran across. So, for example, if your application is using POSIX IO functions, that might be problematic since the DAOS file is not a POSIX file. If you're depending on, for example, both netcdf and cgns, both examine the first 8 bytes of the file to see what type it is, and doing that type of operation won't work because there is no first 8 bytes, and that even if you're using unified namespace, there's a file there, but it doesn't contain any of that information as it's not POSIX. So you'll probably have to skip those. There's also a lot of deprecated API versions. So if you're using very old API versions that have been deprecated, odds are that hasn't been ported over to use the DAOS file. So those probably aren't supported. So you'll probably have to update your application to use the newest version of each API. Oh, and another thing is if you're using an older HDF5 library format that might not be compatible with the DAOS file, you'll probably have to update to use the newer HDF5 version. So I think that's all I had to talk about the DAOS and how some pitfalls you might have encounter when you, I guess, start to port your application to DAOS. Any questions?
Hi, Scott. This is Marta. Maybe what is the system that you use for your tests?
That was the test bed system. That was GLSC that when they first started.
Okay, thank you.
Mm-hmm.
What's the largest installed system at this point that has DAOS? And so what are people saying about scalability compared to how the file systems they are used to?
I think Marta you might correct me if I'm wrong because you might know more about it than I have, but I think they're just starting to make DAOS available on the. It's not available on Crusher yet, is it? I don't think.
Crusher is the OLCF.
Oh yeah, Crusher, not Crusher.
Sunspot, you mean?
Sunspot, yes.
Yeah. Well, Sunspot is I don't know if I can say how many nodes it is, but it's a testbed for Aurora.
Yeah, it's pretty small, Sunspot. So I think the most we've run is the JLSE, where it was a precursor to Sunspot. That was the testing, and I think that was 128 was about the max we could run. So that was the max, and I think it's still the max at this time. But that's going to change within the next month once Sunspot gets up and running. This should be a little bigger, but it won't know until Aurora really comes online.
So it's too early to tell, because
Yes.
that will be really interesting to see how it performs in real life.
Yes.
Sorry, maybe I missed it from the beginning. Do we need any particular version?
Of HDF5?
Yes.
Yeah, you'll need 114.
Okay, 114. Thank you.
Scott, this is Robert. I had a question. Once you have the DAOS vol, does the use of H5 repack to go between the DAOS vol and the POSIX file system, does that largely come for free?
Yes, once you connect to once you give it the path, then the tools will automatically use that DAOS file. So if you say in a H5 repack, you can say what your original format file is in and what you want to be the output file format to be in. And then it should, as long as it can find that path and you set that environment variable, it should just automatically handle that.
All right. So this really generalizes much beyond the DAOS vol. It will hold true for going between any compliant vol and, let's say, for this example, a POSIX file. Okay.
Yes.
And on your table below, the third item there, it says under porting issues, use of native only HDF file driver. Can you elaborate on that third line there a little bit?
Yeah, so if you have APIs that are specifically for the native, such as file size, right? What does file size mean in a DAOS object? Since it's not really, it's a file, but there's no POSIX file size. I don't know if that's been fixed, but I think it didn't used to work with DAOS, that it wouldn't know what file size to return because there's no file as an object store, right? So it's spread over many things. So that's just an example of one that's native. I have to look at the other APIs that are specifically POSIX related APIs.
Okay.
Right. When we decided what was going to be a vol thing or what was going to be a native thing, it was really what was about, like, if you wanted to just have generic storage, what could something reasonably be expected to return? And so people might be doing things like creating vol connectors based on things like relational databases, things like that. And how would you find out how big your storage is? Like you'd have no idea, right? So the ability of an arbitrary vol connector to return something like that is not guaranteed. So we decided to not make that a part of the vol connector. And then nothing that was deprecated was included because it's deprecated.
Yes.
Things like comments and stuff like that are not in there.
Okay. Okay, thank you.
Where is the so the call it the object layout, that specification, is that part of the DAOS vol connector repository, or where is that stored?
The what? Sorry.
Well, there should be, like we have the file format specification for the sort of native arrangement, there should be a DAOS object layout specification, call it that for lack of a better term. Is there such a specification document, or is it, yeah, the documentation is the code?
I'm assuming Intel has something about how the objects are laid out on the file system itself, but we don't document that, no.
No. What I'm talking about it is, how do we represent HDF5 in DAOS objects? Where is that mapping specified? So there must be something, let's say I create a group. Well, that group will be represented by one or more DAOS objects.
There's at least a paper that we wrote on that.
Right, but a paper is a paper, but is that at the level of specification that the, let's say, the file format specification is?
Right. Ideally, that would live with the vol repository. I don't know if that's true, or the vol repo, but I don't know if that's true or not.
I don't, yeah, I thought we put it there, but I don't know if I'd have to look.
Yeah.
I thought it was under documents.
Mm-hmm.
Scott, could you put the URLs to where the repository is on GitHub? I think it was on the first slide.
Oh. Yeah, let me.
Looking for the DAOS vol repository.
Got it. Yeah, thanks. Thanks, Lori. Got it.
I think that's right.
Yeah, that's right.
There's nothing else. Maybe that's it.
And we'll have Garrett next week. We have a 5th Tuesday, so it will be Garrett with materials. And if you have any questions for him. Thank
Right.
you.
Okay.
It's gonna be
Bye.
fun. Don't miss it. Bye.
Bye.
Have a good